Show that x plus 1 is a factor of this cubic. So I'm going to let the cubic be f of x. And then I'm going to substitute minus 1 into the function. That will give me minus 2 plus 3 minus 1, which is 0. Then we can quote the factor theorem. Which says if f of a is equal to 0, then x minus a is a factor. So here, x plus 1 is a factor. Okay, so that's helping us out. It's finding a factor. We're probably going to use that later on. In fact, I'd be amazed if we didn't, given it's just this 1-mark question. And then we've got to solve this equation. Okay, now something that is worth writing down straight away is that there's going to be some restrictions on x, because when we start squaring, which is what we're going to have to do, you can sometimes introduce extra solutions which are not real. If I just look at this one over here, I can immediately see that x is going to have to be greater than or equal to minus 3 over 2. There might be a condition on the quadratic, but I'm going to leave that on because it's a little bit trickier to see. But if you can see like straight away conditions like this, I think it's worth writing them down. Now, I'm going to square both sides. There's not really any easier way to do it than squaring both sides straight away. In fact, I think this is the best way because immediately I'll get rid of the square root on the left-hand side, which is the most awkward term. So square both sides. Then squaring the left-hand side becomes x squared plus 2x plus 5. And that's going to equal x plus the square root of 2x plus 3 multiplied by x plus the square root of 2x plus 3. I'm just taking it slow. So then I'm going to multiply the brackets to give x squared. Then I'm going to get x times the square root of 2x plus 3, but I'm going to get that again. So I can just put a 2 in front, and then I'm going to get the square root of 2x plus 3 squared, which is simply 2x plus 3. Right, now immediately the x squareds cancel. That's good. Still got a square root going on. So what I'm going to do is, I can also cancel the 2x. I'm going to minus 3 from both sides, giving me 2 equals 2x times the square root of 2x plus 3. And I'm going to also divide through by 2. So I'm just making it a little bit simpler. And now I'm going to square again to get rid of that square root. So 1 equals x squared multiplied by 2x plus 3. 1 equals 2x cubed plus 3x squared. So 2x cubed plus 3x squared minus 1 is equal to 0. And we've got a cubic to solve. Now, let's just take a look right at the very beginning. It's exactly the same cubic. So x plus 1 is a factor, should probably say from a. Also, this is when you get to this stage, like you can be really confident you've done everything correct because of the fact we've got the same cubic as in part A. Hey, now that means that x equals minus 1 is going to be a solution, which does satisfy this part here, but we'll check later on whether it actually works. I'm just going to find all the solutions first. So I'm going to do a polynomial division. X plus 1 divided into, there's other ways to do it, but this is just a really good method that works for all sorts of scenarios, including when you divide by x squared terms, for example. Okay, put a little placeholder for x, 0x, and we know that there's going to be no remainder. X is into 2x cubed, go 2x squared, multiply back through, and subtract. x squared plus 0x. We get a plus x here. We're going to get minus x minus 1, which gives us minus 1 here. And there's our remainder of 0. So we've got x plus 1 multiplied by 2x squared plus x minus 1 equal to 0. I'm going to factorize the quadratic now. It's going to factorize, then I've got to have a 2x and an x, got to have a 1 and a 1. I just need to get that plus x, which I can get by making this plus and this minus. So x equals minus 1 is actually a double root, or x is equal to a half. Now, don't just leave it like that. We just need to check that it works, because remember, we've squared along the way, and we may have introduced what we call spurious solutions, solutions that do not actually exist. And whilst I pointed out that minus 1 didn't cause problems in the square root on the right-hand side, it doesn't actually mean that it's going to work. So let's test them both. So test both. Okay, x equals minus 1 gives the left-hand side equal to the square root of 1 minus 2 plus 5, which gives me square root of 4, which is 2. The right-hand side is then equal to minus 1 plus the square root of 1, which is actually going to give 0. So it doesn't check out, even though actually we can put it back into both expressions, it doesn't actually give an equal answer. So reject solution. It's just this solution's been manufactured by squaring the terms where we lose some of the aspects of the square root and so on. Let's just check x equals a half. Now the left-hand side is going to equal the square root of a quarter plus 1 plus 5, which gives the square root of 6 and a quarter. 6 is actually 24 over 4, so we're going to get 25 over 4, the square root of, which becomes 5 over 2. Then the right-hand side is equal to a half plus the square root of 1 plus 3, which is a half plus 2, 2.5, which is also 5 over 2. So this is a solution. Overall, x equals a half is the only solution to this equation. Well done.